Assalamualaikum warahmatullahi wabarakatuh. Allow me to introduce myself. My name is Putri Isu Wachufyah. I am from Ronggolawi University. Today, I would like to discuss about effect of problem-based learning with metacognition approach on mathematical problem-solving ability. Research result from Kenny Sri Elita et al. First, I will explain to you about an abstract result. Students have difficulty in solving story problem, asking questions, taking steps to solve, and solving the problem given. The purpose of this study was to determine the effect of problem-based learning model with metacognition approach to student mathematical problem-solving abilities. This type of research in experimental study using a quantitative approach. The instrument used was a description test. The population in this study was 8th grade students of MTS Semerah Kerinci with a total of active 4 people. Sampling is done by some simple random sampling. Data analysis of problem-solving ability is done using the t-test. The results show that there was an influence of the problem-based learning model of learning with a metacognition approach to student mathematical problem-solving abilities. The first, introduction. According to book, mathematics is not just a collection of formulas and calculation only, but can be applied in everyday life to solve various problems and meet practical needs. And Putri, Suryani, and Jeffrey, problem solving is a process to overcome the difficult phase to achieve the expected goal. Based on the observation of research at Madrasah Sanawiyah Negeri Semarang on the learning process, it showed that have difficulty in solving problems in the form of stories or description given in addition. Students also have difficulty asking questions from the problem present, making their own step in solving problems, and students often waiting for the teacher to convey mathematical formulas rather than looking for them. Students only think about the final result in a problem, or students are less able to solve problems with correct and logical procedure without any effort or determination from students. According to Rusman, problem-based learning is learning model that guides solving problems with 5 steps. First, orienting student to problem. Second, organize student to learn. Third, guide individual and group investigation. Fourth, develop and present the work. 5, analyze and evaluate the problem-solving process. According to Smita, metacognition is serious process because we use our cognitive process to reflect on our own cognitive process. Metacognition has 4 characteristics. Number 1, knowing the goal to be achieved through the thinking process. Number 2, choose a strategy to achieve the goal. Number 3, observing the process of developing self-knowledge. the C to see whether the choose strategy is correct. And then evaluating the result to find out whether the goal have been achieved. The purpose of this study was to determine the effect of problem-based learning with a metacognitive approach on the mathematical problem-solving abilities of 8th grade students of MTSN Semarang. Then I will explain method in research. This study used a quantitative approach that is processed using statistical method. The type of research used is experimental research. Population. The population of the study were active for students. The sampling was done by simple random sampling. Select class 8D with 70 students as the experimental class and class 7A with 70 students as the control class. Data collection technique. In this study, the data collection technique used was a test technique. The type of instrument is in the form of a description test that serves to see student ability to solve problem. The test was the test in the fight to find the validity, the reliability test, the difficult index test, and the discriminatory power test of the 8 test question. Next, the validity, the reliability, the difficult index, and the discriminatory power. Number 1, the validity test. 5 valid criteria question and 3 questions did not meet the valid criteria. And the reliability test, a value of 11, the value of R11 equals 0.58. 0.48. Meaning reliability 0.4 less than R11 less than or equal to 0.6, including sufficient correlation. And the difficulty index, 3 questions in the easy category and 5 questions in the moderate category. The discriminatory power, 3 questions in the very poor category and 5 questions in the moderate category. Written problem solving data and documentation is number 1, relate to student data. Number 2, photo of answer sheet for mathematical problem solving ability test. Number 3, facilities and infrastructure. And then photos of learning process activities. The step to draw conclusion from the final test data. To analyze the data in the form of an average comparison of the mathematical problem solving ability of student learning between the experimental class and the control class was significant or not based on the result of the final test. Number 1, the Lilly 4 test for test normality. Next, the test the homogeneity of variance, use a v-test, and the similarity of the two sample class average, use t-test. Number 3, I will explain to result and discussion. Result. On Table 1, summary of the comparison of the problem-solving ability score of the experimental class and the control class. Amount experiment 1, 2, 3, 4. Control 1105. Average 72.58 and control 65. Standard deviation experiment is 8.74 and control 8.4. Variance in experiment is 76 and control 70.62. Based on Table 1, it can be concluded that the mathematical problem-solving ability of students will use a problem-based learning with a metacognition approach is different from those using conventional learning. In Table 2, summary of normality test for experimental class and the control class. Total student experiment and control is 70. L0 in experiment is 0.1443 and control is 0.1929. L table in class experiment is 0.206 and control class 0.206. Based on Table 2, it can be concluded that the two sample classes are normally distributed. The homogeneity of variance test in Table 3, summary of homogeneity of variance for experimental class and the control class. Variance in experimental class is 76.5 and in control class is 70.62. F count is 1.0832 and F table is 2.33. Based on Table 3, it can be concluded that the two samples have homogeneous variance. The hypothesis test. The hypothesis was tested using t-test analysis. This test is conducted to prove whether the hypothesis is accepted or not. After analyzing the data, obtained t-count of 2.5776 will value t-table is 2.0378. This means the value of t-count is greater than t-table. So, in this case, it means that H0 rejected and H1 is accepted, meaning that there are different mathematical problem-solving abilities between the experimental class and the control class. And then discussion. In discussion, the relationship between problem-solving abilities and problem-based learning with a metacognitive approach, namely problem-based learning model is running model carried out through group discussion so that students can express opinion to solve a problem and exchange information. Problem-based learning is giving problems related to everyday life to each group of students to find alternative solutions to this problem. And the metacognitive approach provides a way of controlling the mind which will ultimately result in the ability to think critically, which is very much needed in solving mathematical problem solving. Step problem-based learning model with metacognitive approach. The first step, group formation, and the second step, giving conflict. The third step is identifying the problem, and the fourth step, problem solving. The fifth step, presentation of result, and the sixth step is evaluation. Judge from the learning process. The problem-based learning with a metacognitive approach can involve students actively in learning, especially when organizing students to learn, guide group investigation, presenting work result, and evaluating problem-solving result. The metacognitive approach refers to an understanding of the knowledge it has that can reflect its effective use. In the learning process, students actively discuss in asking and answer questions, and this can be seen when students work on student worksheet. Students who do not understand ask their friends, while those who already understand explain to their friends. In the learning process in the classroom, the problem-solving abilities of students who use the problem-based learning with a metacognition approach have a higher value than those who don't use the problem-based learning with a metacognition approach. This is caused by students in class experiment that use a problem-based learning with a metacognitive approach are actively involved and can control the learning process, starting from the planning stage, causing the right strategy according to the problem at hand, then correcting if there are errors. Based on the result of data analysis, which is significant mathematical problem-solving ability between group of the students who are taught using a problem-based learning with a metacognition approach and a group of students who are not taught using the application of a problem-based learning with a metacognitive approach. Positive impact on the implementation of learning activity in the classroom. Through the use of the problem-based learning with a metacognitive approach, students will be aware of their own cognitive activities or anything related to their cognitive activities in solving problems and training students to think independently. Next, conclusion. There are differences in the experiment class and control class with an average value of 72.58 for the experimental class and 65 for the control class. So, it can be concluded that learning using the problem-based learning, a metacognitive approach that affects student mathematical problem-solving abilities. Suggestion. First, for students are expected to study harder and practice solving math problems. And second, as an alternative to the problem-based learning with a metacognitive approach, teachers can use mathematics in learning mathematics to improve student mathematical problem-solving abilities. Third, it is hoped that further research will be carried out to determine the mathematical problem-solving ability of students in different schools and material. Thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.